Welcome to an insightful journey into the world of memory, learning theories, problem-solving, and decision-making. We'll explore key cognitive processes and their applied implications. Memory functions as a complex system of encoding, storing, and retrieving information, much like how a computer processes data. It's essential for learning and decision-making. Memory processing involves several stages, starting with encoding, where sensory input is transformed into a format the brain can process. Storage then maintains this encoded information over time, depending on effort and relevance. Retrieval is the process of accessing stored information. It includes recall, recognition, and relearning, each playing a crucial role in how we use memory in everyday tasks. Memory is a composite of interacting systems, distinguished by duration, capacity, and function. The main systems include sensory memory, short-term memory, and long-term memory. Sensory memory is the initial stage of information processing, characterized by very brief retention. It integrates sensory input over tiny temporal windows, crucial for immediate perception. Short-term memory, or working memory, is a limited-capacity workspace for temporary maintenance and manipulation of information, supporting tasks like mental arithmetic and problem-solving. Long-term memory retains information from hours to a lifetime, encompassing episodic, semantic, and procedural subtypes. It involves processes like encoding, consolidation, and retrieval. Learning involves a relatively permanent change in knowledge or behavior through experience and practice. Various theoretical frameworks offer distinct mechanisms and applications. Classical conditioning explains learning by association, where a neutral stimulus is paired with an unconditioned stimulus, leading to conditioned emotional responses and cue-triggered reactions. In classical conditioning, we identify the roles of neutral stimulus, conditioned stimulus, unconditioned response, and conditioned response, essential for understanding behavioral changes. Operant conditioning, introduced by Frederick Skinner, involves learning through consequences. Reinforcement increases behavior, while punishment decreases it, shaping behavior effectively. Operant conditioning distinguishes between active response stimulus and passive stimulus response models, highlighting different approaches to behavior modification. Observational learning, as described by Albert Bandura, involves learning by watching others. It emphasizes modeling, self-efficacy, and vicarious reinforcement, crucial for socialization and training. Learning frameworks are complementary, not exclusive. Complex skill acquisition often requires operant shaping, observational modeling, and cognitive encoding for long-term retention. Problem-solving involves transforming an unwanted or novel state into a desired one. Key steps include representation, strategy selection, monitoring, and adaptation, utilizing expert skills. Problem-solving strategies like means-end analysis, analogy, and heuristics are vital. Accurate problem representation and monitoring progress are essential for revising strategies when needed. Decision-making involves selecting among alternatives to choose a course of action. It contrasts normative models, which focus on expected utility, with descriptive models, which reflect actual behavior. Heuristics are mental shortcuts that aid rapid decision-making. While they can be adaptive, they also produce predictable biases, influencing how we perceive and react to information. Heuristics like availability, representativeness, and anchoring simplify problem-solving but can lead to errors in judgment. Understanding these can improve decision-making processes. Metacognition is the awareness and regulation of one's own thinking, a concept introduced by Flavel in 1979. It involves skills like planning, monitoring, evaluating, and adjusting strategies. Developing metacognitive competence can significantly enhance problem-solving, decision quality, and learning transfer. Instruction in metacognition yields measurable benefits, making it a powerful tool for personal and professional growth. Metacognition plays a crucial role across various domains. Memory provides the informational substrate for problem representation, while learning shapes the repertoire of heuristics and strategies. It governs the selection, monitoring, and correction of cognitive processes, with applications in education, clinical psychology, and organizational consultancy. This cross-domain interaction highlights the versatility and importance of metacognitive skills. The implications of metacognition are vast, with practical interventions across different fields. In education, techniques like spaced retrieval, mnemonic instruction, and metacognitive training are employed. Clinically, conditioning-based therapies, skill training, and memory supports are utilized. Organizations benefit from decision support systems, debugging techniques, and structured problem-solving. These interventions demonstrate the broad applicability of metacognitive strategies. In summary, memory, learning, problem-solving, and decision-making are interrelated cognitive domains. Multiple theories provide complementary explanations and practical tools. Metacognition and applied interventions can enhance performance across settings. Ongoing research continues to integrate cognitive, neural, and social perspectives, underscoring the dynamic nature of this field. Thank you for watching and investing in your learning journey with us. If this video sparked new insights or helped clarify a concept, give it a thumbs up and share it with someone who'd benefit. Subscribe and hit the bell so you never miss a chance to grow with us, whether you're a student, educator, or lifelong learner. Got questions or ideas? Drop them in the comments. We read every one and love building this learning community with you. Until next time, keep questioning, keep growing, and keep making education count.